Merry Christmas, everyone! I hope Santa brought you some nice things. I got a new shirt. Thank you, Santa. I mean, honey. Hey, I have a gift for you. I'm putting together a presentation here on machine vision algorithms for surface curvature estimation. Let's let the computer do the computation. Incredible results. Let's dive in. Notice how the clouds move faster in the foreground. This is the effect of parallax, and we'll be exploiting this phenomena to calculate the surface curvature. Okay, here's the basics, all right? We're going to be slicing up the images in thin strips and do a cross correlation to determine how much they're shifted relative to each other. And then we will process the parallax that's available in our images. Here's a slightly more detailed graphic here. So we take thin slices and we feed those into an image phase cross correlation subroutine. This particular algorithm has been around for a long time, I believe since the 1970s, first described in some papers. It's much faster than using the autocorrelation or cross correlation function. Okay, so we do that and we slide the red window across the image, okay? And as we approach the horizon, the shift is very small and then goes to 0. As you can see in the upper left there, I've extracted the shift, the horizontal shift. And then by knowing the pixel shift and camera information, we translate the X and Y pixel differences into angles, okay? And down in the lower left, then we take advantage of parallax. And there's the equation. And also the dip angle, a sine and a cosine, which is not shown. And we can output a surface profile. Isn't that incredible? So notice here the cross correlation. We get a peak, which represents the shift, okay? And what's neat about this method using FFTs, we can do subpixel correlation, and notice how smooth it comes out. As we can see here, folks, this is incredible. We can see out to 5,000 miles. It just blew me away. But obviously, the closer you get to the horizon, the more air affects us. So the accurate data is really, around 1,000 for this particular case. And over on the right, I've zoomed in and notice how nice and smooth the surface is. But yeah, this is just incredible, folks. Just wow. We plot the Earth curvature for comparison. Notice how pathetic it looks. Oh my goodness. So that's not really the Earth's curvature. It is the curvature due to light bending. The curvature of light bending, the radius, okay, because there's refraction. That's really what that is. But when we look at the surface of the Earth from aircraft, it is incredibly flat. Now, it's important to make sure you got all the pixel size correct and the focal length. Otherwise, the results don't come out right. This is just incredible, folks. I estimated the surface curvature to be about 1,000,000 miles. Wow, it just blew me away. And notice that these images are not infrared. They came from my cell phone. Anybody can do this. And I have a surprise announcement towards the end. But this is just incredible. However, I kind of started doubting the information from my camera, and so I turned to my infrared images. Flying around on business trips, I've accumulated hundreds, if not thousands, of incredible infrared images, as you see here. This particular one and a few others in the same set were on approach to Chicago, somewhere around here, okay? And I've taken a few of these clips and aligned them so I can process them with the machine vision algorithm. The results are just incredible, as you already know. Most of my viewers over the years know the content of this channel. Yes, this is incredible, folks. We can see out quite a ways out. And what I've done here also is average the surface. So I get a very smooth surface. Here I'm illustrating curve fitting to a line and then looking at the residual. Eyes can be deceived, folks, really, but the algorithm and the FFT can really pick out the fine shift close to the horizon. In the past, I've made statements that this is absolutely flat, but as you can see, it is not. And the question is, what's making the curvature? Is it refraction? Is it surface variations? Or is it really the underlying ellipsoidal or local curvature? Yeah, something to think about. In all of my years, folks, I've accumulated so much information. Look at all the flight paths. I've gone on many business trips, and I've come to the conclusion that the Earth cannot have the estimated radius of 4,000 miles. No way. It is incredibly flat, and science tells us that it's really refraction that's doing it. But I've turned to infrared so I can see farther and straighter because longer wavelengths bend less. And I'm blown away. The Earth is incredibly large, at least in this part of the world. Walk you through my code real quick. So here I have a for loop and I segment the thin strips and then send them to get shift to calculate. This is the get shift function. Okay, the FFT is there in the center, and then I find the maximum. Let me highlight it. Here we go. So that's the core of it. Image 1, image 2, and then we multiply image 1 with the conjugate of image 2, and then we invert it back to the spatial domain, FFT shift, etc. Now here I have the surface plotting function and the different radii that I'm comparing with. So pretty nifty. So with a slight adjustment of the horizon, um, we can change the angle of the surface slightly or as much as we want, and then we can curve fit. And here I've been doing it kind of manually, eyeballing it, because it's really a hard problem. You really don't know what's affecting you and where you're measuring the curvature. But I've come to the conclusion that it is large, over 100,000 miles to a million, which is incredible. So there you have it, folks. And here's the special announcement. I'm going to be packaging this code into a nice graphical user interface, and I'm going to be releasing it so everybody can do this. You don't really need an infrared camera. If you're flying over clouds, you can just image the top of the clouds, and as you've seen, you can get pretty good proof that the Earth is incredibly large. So stay tuned for that, folks. Anyway, Merry Christmas once again, and God bless you, and hope to make another video shortly. God bless you. Happy 2025 if I don't see you guys by then.